This is homework 9, question 7. We have to show that random telegraph signal is SSS, strict sense stationary. Here, so to show strict sense stationary SSS, we need to show that the distribution functions at time joint distribution functions at time t1 t2 dot dot dot, all these, any random time that you take, when shifted by epsilon, and it can be any epsilon and any t1 t2 dot dot dot, they are the same. The distribution functions are the same. So that is exactly what we are going to prove here. Now, so for a random telegraph signal, or rather for a semi-random telegraph signal, xt is defined as this. It is 1 when the number of points are even. So underlying it is basically a counting process. So number of points is even and xt is 1. And in a semi-random telegraph signal, usually x0 starts from 1. So it always starts from 1. So if you take any two intervals and k is even, so we'll get 1, right? Between 0 to 2. And for making it completely random, we add another variable a. So probability of a equal to 1 and minus 1 is half. So it can start either from 1 or minus 1. So now we want to show that the distribution functions will be equal even when we shift it by some random time interval, random interval. So as you can see here, so probability of ytn equal to 1 given ytn minus 1 equal to 1 dot dot dot, all these, and then we can write it as this because it's a random telegraph signal. Only depend on the previous one. So if you know the previous one is equal to 1, it only depends on that. So and then we can represent this random telegraph signal as, like I said, it's underlying, it's a counting process. So we can represent it as this: e to the power of minus lambda t cos h lambda t. So we write it as e to the power of minus lambda tn minus 1 cos h lambda tn minus 1. So, and this is using Bayes' theorem and total probability theory. We just break these terms up. So probability of ytn minus 1 dot dot dot, we can write this as ytn given ytn minus 1 dot 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 ytn t1. And then basically if we forget this, then we have to again take probability of ytn dot 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 ytn minus 1, and we can further break that term into probability of ytn minus 1 given ytn minus 2 dot 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 yt1, and again like that we keep breaking on, so we get all these terms here, right? And since I already said that it only depends on the previous value, ytn depends only on ytn minus 1. So all of these terms become like given only one term, so like this. So all these are functions of tn minus 1, right? And this last term yt1 is half, because you know it is half going to be plus 1, half going to be minus 1. So and then we can write this as e to the power of minus lambda tn minus 1, because I said these are functions of tn minus 1. So I'm just showing you how, like that. And so it only depends on ti minus 1, right? So yeah, so it does not depend on the amount we shifted by it only, and yeah.